Alright, we've been working on finding equations of lines, and one of the skills that's kind of useful is the ability to take a bunch of different ideas and apply them to a new concept. So in this chapter we learned how to graph lines when they're given to us in standard form. We learned how to find equations of lines passing through different points. Now we're going to combine the idea of not finding the equation of a line that's based on given information, just knowing a point and a line. What if we wanted to find the equation of a line that's perpendicular to or parallel to a given line? So how is that going to be different? So the point of this is to show you that there really is very little different here. The first thing I want to do is to graph the line so I know what I'm looking at. So the first thing we need to do is graph y equals 2x plus 5y, 2x plus 5y equals 11, and recall the intercept method for doing this. That is to say, if you let x equal 0, put in 0 for x, you get 5y equals 11, so you have the the y-intercept. And if you let y equal 0, that yields the x-intercept. Two very easy points to plot, which means we have two solutions to the infinite solutions, and all the rest are going to fall on the line between them. Then I plot the point 3, negative 5, and to the best of my ability, I try to draw what looks like a right angle, so I create perpendicular lines. Now this is just a sketch, but it is going to tell me that I'm looking for a line whose slope is definitely positive, definitely bigger than 1, and whose y-intercept is going to be negative big number. So if all of that happens, I'm going to feel good about my work. I need to figure out what the slope of the given line is, and there's a couple ways you can do that. One of the ways is to take this equation right here and solve for y. So doing, I get negative 2/5. Another way would be to take your change in y over change in x, that's 3 1/5 over negative 5 1/2 to get the slope of negative 2/5. But either way, that is the slope of the given line. I'm looking for the slope of the line perpendicular to that, which we discussed in class. Perpendicular lines have slopes that are both opposite one another, one going down, one going up, and reciprocals of one another, one flat, one steep. So, I need to find the equation of a line. Whenever I'm asked to do that, I'm really asking to walk home a line with a point and a slope. So I use the point-slope form. The y is given to us as negative 5, the x is given to us as 3. We distribute the 5 halves, add 5 to both sides, and I get this answer, or this result. So this is the equation of the line that I was looking for. It has a negative y-intercept, positive slope bigger than 1, which match my criteria. The only problem I'm concerned with is the negative 12.5. I count down to negative 12.5 and it doesn't quite work. It's very possible that my picture is flawed, that my picture is not accurately representing the situation here. It's just giving me a general idea. So I go to technology. Here you can see I entered in the line that was given to me. I entered in the point 3, negative 5, and then I took my answer and typed it in, and I wanted to make sure that my line went through that point and that it also was in fact perpendicular, just from eyeballing it, to the line that was given. So just to verify, the graph that I had looked like this. And it's not perfect. You can see the intersection that I drew is a little bit different than the actual intersection, and there's subtle differences in the nature of my drawing, but that was a freehand drawing to give me a sense. This is the technology. It's close enough for my liking, and I have absolute confirmation that this is, in fact, the line that the author was looking for. Hope you find that helpful. Have yourselves a great day.